So thanks all for joining. Today I want to show you a little bit more about our digital wind tunnel app that we've been developing, and yeah, to really get your own hands on it and play around with it as well. I've specifically not put the files in the Google Drive folder yet. I'll do that in a while. What I was thinking first actually is to start with some introductions. I kind of want to get to know you guys as well. Like, what are you doing? What's your experience or interest in CFD, and what do you hope to get out of the workshop? From there on, then I'll do a bit of introduction of what at TT we do in terms of CFD, specifically looking at flow around buildings, and then how that leads into the Nuada.CFD app, like giving a bit of background really where we came from. Then let's have a little break, and I'll drop the files in the Google Drive. So after the break, we'll make sure that everyone has the app installed. So all that you need to know now is actually you need to have Rhino 7 running. 6, it should work as well, actually, Rhino 6 or 7. And then I'll provide you with a plugin at that time. We'll go through it to actually install it and get it working. We'll then set up a project, setting up a presentation. Setting up a project. So I'm planning to kind of run through it with you together on the sample file of the City of London that I have, and then the last chunk, that's probably the last hour or so of the workshop. Yeah, feel free to try it on yourself, and we can answer any questions that you have, and we can just treat them. Yeah, as we go along, share the screen and just try to resolve them. Let's see how that goes. I mean, we're quite flexible. It's not a strict timeline, but it should keep us busy for the next 3 hours or so, right? So first of all, myself, I'm Jeroen Jansen. I'm an associate director within Core Studio, based in London, and so within Core Studio, we got our core modeling. So that's a group really involved in projects, ranges from complex geometry to interoperability to go from a certain software to a certain software. And I'm doing a little bit of that within the London office, and as well coordinating with architects going into the meetings, etc. The other part is application development. So I'm also having a little branch in that with the CFD app. And on the other half, let's say, of my job is CFD, it's wind studies. And as of that, we got these, we call them communities of practice within the firm globally. I'm leading the computational fluid dynamics group, and that's really kind of getting together all of the heads within Thornton Tomasetti that do CFD, let's say. So I'm an architect by education. So I've done my 5 years undergrad in the Netherlands, then came to London for a postgraduate course at the Architectural Association. And from there on, I actually rolled into the computational side of things and learned the CFD on the job, really. At my previous job, and then 3 years ago, I joined Core Studio. So what I was thinking is to first go through a little presentation, just to give you a better background of really what does CFD, computational wind engineering, mean within TT, let's say. Okay, no worries at all. So what does that mean? And then with that, you'll see, and I hope to show, let's say, why we started thinking about a workflow really to kind of streamline all of these processes, all of these projects. And that eventually led to the Nuada.CFD app. Because really the second topic is we want to design with wind, right? We want to do quick iterations, early stage Rhino models, and then run a simulation quickly and get results back into into the 3D models and work with that, design with that together with the wider team. And then we'll dive back deeper into the app. So I'll introduce it briefly. I got a few recordings of videos of how to launch and run your own your project in the app, and then visualizing it. And then after that presentation, what I was thinking is have a break, install the software, and then we'll actually dive into really get our hands dirty on the software, let's say. Right, so let's get into it. Basically at TT, well, let's take a step back first. I mean, CFD is a big, wide field of research, of work, of different types of projects. And within TT, we have a few groups that do that thing. So let's say a pipe burst and your CO2 leaks out and rolls over a hill. What's the risk of that? Or an oil tank collapses, and does it stay in the perimeter? We got a group that does the total opposite and that models. This is the life sciences group in San Francisco. They model like Silicon Valley. They model like heart valves and blood vessels and that sort of thing through CFD. None of that today. I'm basically focusing on buildings, wind flow around buildings, and that really comes into a few scales. So that's on the master planning scale. So, and that's very early stage, right? Everything is still digital. So how can we draw the wind in or keep it out, depending on which climate you're working in, and actually make comfortable spaces, right? So to calm down the wind, often in the more, let's say, Nordic countries, let's say, and in the more temperate zones, you might want to increase wind speed to actually get a cooling effect. Oh, that's a bit too quick. We've been using it very early stage in competitions as well. So for instance, on that tower in Athens, looking at the pedestrian comfort at ground level or at the private balcony levels. So really to create comfortable environments on these large residential balconies. In a couple of sports venues, so the arena in the center, it's really about having comfortable spaces and safe spaces around the stadium, so where people queue up and gather, so that it's not too windy, or where we specifically looked at the moving some tennis fields for Tufts University, and what is the effect of the new location on the fields, really on the play. And more and more as well, it goes into pedestrian wind comfort, and that's especially in the United Kingdom, that's a planning requirement for tall buildings. In the US as well, more and more cities are picking it up. Clients are becoming aware of it, and it becomes more of an important thing. So you would really look at 1.5 meters above your ground level, plus roof terraces, running 16 directions around the windrows, or 36 or whatever, and then comparing that results, those 16 results, with the windrows, and you can then look at how windy is it in these locations over the year, and are these spots comfortable for long-term seating, your restaurant terraces, that sort of thing, to standing entrances, walking up to uncomfortable. So these are a few of those projects that we've done in that respect. And this really described that. So you got your 16 directions, compare that. So in this case, it's the windrows for London on the left. You compare that with the probability of the wind coming from that direction with that certain speed. And then you can convert that into, there's a few of those comfort criteria. This specific one is the Lawson comfort criteria for London. And you can then basically say if the wind speed, it basically says for 95% of the time of a year is below 2.5 meters per second, then that falls in the category of frequent sitting, which is applicable for a restaurant terrace, a cafe, and then gradually goes up to walking conditions or even uncomfortable. And then you just need to prove with your new building that you're not making conditions worse, basically. And if you do make conditions worse, you can either change the massing of the buildings or add canopies and have that, or vegetation. That's a mitigation. The problem, what I found often with those, is that because you're going for planning, actually the design is so settled and everything is coordinated. So it's really difficult to update the geometry at that point of the massing of the building. So often it is actually, I found mitigation a really ugly word, let's say. It is really mitigating the effects. I'd rather be much earlier in the design phase, where you can actually scope the building to remove a lot of those bad conditions, let's say. We've been dabbling a little bit with other things, like especially say a year ago or so, when we started thinking about coming back to the office. So what do we do with indoor air quality? And this is looking at the age of air. And you see that those little, the smaller cubicle offices were doing a lot worse compared to the open plan office in terms of ventilation. This was a quick study. This was a bit more involved. So this is the Harvard Art Theater at Harvard University. It's a naturally ventilated theater. So there's two theater rooms, 200 people. I think this is the largest for 200 people, and they were all naturally ventilated. So the fresh air comes in through a labyrinth below the ground floor. It's been sucked in through openings in the ground and below the seating, and it's been sucked out naturally through two chimneys, two wind catchers at the top. And the question here actually was, when there's a play happening, so you have a full capacity of 200 people, if the play is going on for 2 hours, the people on the top balcony, are they still comfortable in terms of temperature at that time? So looking at the airflow of the natural ventilation, but also the thermal stratification. And another one we've been looking at with our sustainability and facades team is this double skin facade. So we're looking at a section of, I think it's a meter and a half wide. It's 60 centimeters deep. So what is that, 2 feet deep? Double skin facades. And what are 3 conditions of this cavity, for instance? So I think they're all summer conditions. Air comes in from the bottom, goes out to the top. On the left, I think it's, if I remember correctly, just open and there's no blinds or anything in there. The middle one is a summer condition where there's, you just see on the right-hand side little stripes. So there's a set of aluminium blinds in there. What's the effect of that on? So we're looking at temperature here on the inner pane, and the right-hand side, I believe that was an active fan driving the air out. And what's the effect of that? And you see the temperatures dropping in that cavity. So that's a little bit of an overview of type of projects that we've been doing within TT. And as I said, really what I'd like to do is get in early. So really at your competition, concept design, early schematic design, that's the type of projects where you want to look at everything is still in 3D. It's relatively easy to change massing. And so, for instance, you could look at a few options. So in this case, a single tower, 3 directions. What is the effect of adding a podium to it? What is the effect of if it's not 1 tower, but 3 towers? So they actually start to interfere in terms of wind, plus playing with the spacing of those. So just running through them quickly and how does that work? We've seen this one in the previous slide. So as I said, this was competition stage actually. We had a relatively detailed model from the architects. So we just threw it in and looked at pedestrian wind comfort. So this is 16 directions all the way around, looking at the local wind climate. So this is right at the coast in Athens. And are these balconies, these were very large private residential balconies, high-end residential development, of course. So the key seller was that balcony. And actually, they're actually really calm. The whole red areas that you see, that's actually just at the tip. The balconies the balustrades were inclined. So actually that area was not reachable. So great design, actually. Unfortunately, we didn't win the competition, but the wind showed a good picture, let's say. And then bringing it to planning. So this is a project in London. There was a building on site. We're now building, I think it was 16 or 17 stories back, student residential with a rooftop balcony and a loggia set in. So what's the effect of this building on the wind around it? But really important, what I found as well is what in terms of requirements of doing these early stage design is clear graphics, is communication, right? Like getting in, and that's the great thing I feel about CFD compared to even a physical wind tunnel test. You have all of the information, so you can actually cut big 2D planes and get colored graphics on. And yeah, they represent comfort value. So they actually represent the areas of where is it comfortable to sit down. So that's where your restaurant terrace should be. Or if that area of your restaurant terrace falls out, maybe we need to move that or that sort of thing. So it becomes a design decision, really. And the thing that we've been looking at more recently, and little disclaimer, this is not in the app yet, because it's a bit more difficult to say, is wind loading on buildings. So average loading, we can look at it, but if you really go into more dynamic effects, that's a bit more tricky, and we're pushing hard. So bear with me for a second, because this part goes a little bit technical, but I still wanted to show you where it's going, let's say. So we've been doing a piece of research together with Western University. So they're in Canada, in Ontario, London, Ontario, in Canada. On this specific building in Philadelphia, they've done a few years ago when we were doing the design of the building. Thornton Tomasetti was the structural engineers. They have done the physical wind tunnel test back then for the design. And they're also masters, so that's their own facility. They're also masters in CFD, and they're really pushing the wind loading quite a lot at the moment. So we've been working together with them, like, actually, let's use that as a validation case to try and get accurate wind loading on these buildings. I'm going to skip a little bit through this, but basically, they are very clearly working with, very diligently working with the Allen Davenport wind loading chain. So looking at the terrain effects, so that's, so there's 5 factors, they're all important. Your wind climate, you can't do much about it. And at the end, your design criteria, which comes from the code, can't do much about that. But the 3 things in the middle, you can influence, whether you're wind tunnel testing or CFD. The terrain effect is an important one, and that's where a lot of quality of the simulation comes from. So an inflow generator, that's what they've, as part of the PhD research, developed together with a roughness model, which is important to kind of set your approach flow. So whether it's urban, suburban, or open terrain, your aerodynamic effect, so that's the actual simulation, and that's the geometry model in there. So how accurately do that? And then the dynamic effects is a set of post-processing rules in terms of getting the structural responses of those buildings out. So we're really focusing on those first 3 boxes, and develop this turbulent inlet generator specifically for open foam. And it's matching brilliantly. So it's not only the easy, I say easy part, is matching, relatively easy, is matching the mean flow characteristics of air flowing over urban terrain. They've also looked at the turbulent effects and basically the statistical dynamic effects of the wind to match that. So this is the comparing a physical wind tunnel test with the CFD in terms of inlet velocity, turbulent intensity profile. So that's the input. And then on the right-hand side, the power density spectrum. That's basically the power density of the air of the wind. So this is without any buildings in there, empty domain, compared to the von Karman, the theoretical power spectra that you want to be and that a wind tunnel wants to be. So that matches really well. As well as then if we move into a single building, we're working with academics, so you need to do one step at a time. You don't just jump into a big urban domain. You first want to look at a single building. This is comparing in those graphs, LES is the CFD simulation versus wind tunnel test. And if your dots are over the diagonal, that means that's a spot on comparison. And it's not only the mean pressures in 3 different angles of attack, but it's also the bottom, the RMS, which is your fluctuating, your turbulent properties. It's actually spot on. I haven't really seen anything like that, to be honest. And then when we were confident with that, we then jumped into the 3D model of the actual building. First of all, it delivers pretty pictures, of course. But then actually the results, so again, comparing those power spectra with experiment versus CFD, you actually see they're pretty well correlating, which is really, really exciting. As I said, this is not in the app yet. This is basically kind of gold standard of CFD at the moment. We want to be with the Nuada.CFD app in that early stage design, quick simulations, almost instant results, say in the hour or so. These simulations, they're fully LES, so they're still working at 3-4 days of runtime each direction. So it's a different magnitude of simulations. So we were looking at base shear, the forces now, the moments also spot on. So yeah, this is where the field is going, let's say, where we want to go, and we're pushing it. With the app, we're firstly targeting slightly different areas. However, at the same time, we still learn from that, and we'll get some post-processing routines in the app based on that research, let's say. Right, so that's TT, what we do. That's the designing wind, what we want to do and sometimes are doing. And with that, we basically get to the app, to the digital wind tunnel app, to the Nuada.CFD. So really, actually, a lot of these projects are quite repetitive, right? So you drop in a geometry, and I'm simplifying it now, but in a way, you drop in geometry, then with a few parameters to set. So it's your terrain conditions, it's your exposure category. So what's the area around it, right? Is it urban? Is it suburban? Is it open terrain? That's one input you need to set. You need to set basically the size of a domain and your coarseness of a mesh and sort of things. But actually, you can automate a lot of that, because that's kind of governed by the tallest building in your, whether it's the building you're looking at or the surrounding buildings. The wind speed that comes in, but actually typically we run it at 10 meters per second, 10 meter height. The wind speed varies over height, so it's a logarithmic relationship, which is based on that terrain roughness, which is the first input. So again, if you automate that, you kind of can take that away. And when the simulation runs, it's then getting the results out and visualizing it. So there's a lot of repetitive work in there. And that's where we really started to look at that workflow and how can we make it better. So that started off with some custom Grasshopper components. And now that really finds its way into Nuada.CFD. So this is a Rhino plugin. So you launch it within Rhino, you'll see it in a second. You can, with 5-6 screens, you basically build up your simulation. In this case, we chose to connect it with the solver SimScale. So what I like about SimScale, there's a lot of solvers available, right? So we mentioned Eddy 3D in the beginning. There's some, what's the name? It's part of the Ladybug Honeybee suite. It's Butterfly, which connects to BlueCFD, which is basically OpenFOAM as a solver, but implemented in Windows. You can go directly to OpenFOAM, you can launch it, but that's a steep learning curve. You can launch that on a Linux machine, in-house, on a cluster, on Amazon AWS or Azure, whichever. You could run it on ANSYS. And then, yes, AD3D, thank you. I think that's indeed BlueCFD. What I like about SimScale is they have a specific solver for urban domains, that is Boltzmann solver, which, without going too much into detail, but technically it doesn't mesh the geometry, and therefore it's actually very gentle with geometry. So you can actually throw in quite a lot of dirty geometry, which means you save a lot of time in cleaning up the geometry. If you're working with an OpenFOAM big model like this, you could easily spend 2-3 days to actually remodel everything. And with SimScale, I've been seeing that drop to almost an hour. The simulation costs some money, so it is a subscription. It runs fully in the cloud, so by default, that runs in the browser. Hold on yet. No, Nuada is not yet downloadable on Food for Rhino. We're still in beta, so we're getting there. I'll drop the files in the Google Drive here in a second, and we'll install it together. So hold tight. So SimScale works on the cloud. By itself, it works in the browser. So you upload your model, start running it. It solves in the cloud, and then you visualize it in the browser. They've opened up an API a few months ago, close to a year ago, and that's what the app is using. So we're pushing it to SimScale, and for this workshop, we'll have a free account set up for everyone to test, so you can actually test it yourself for a few days. And then if you like it, we can chat and kind of connect you and set up a proper account. As I said, it does cost some money to run the simulations, but I think it's worth it with saving the time on not cleaning the geometry. As I said, there's a lot of repetition and settings that you can set, so that's what's coming in the app, and that's where we're getting to. And then the part, it's still in beta version. The part we're still working on is actually getting the visualization back. So you can visualize now, but it's still a little bit clunky, I'm gonna admit. So we'll get there. So basically we're launching today, like a soft launch. So you're actually the first testers of the app. We'll give you access to, as I said, to the SimScale account for this workshop. If you want to know more, either get in touch with myself or with the guys at SimScale, and we'll link you up together. Right, so that's the background. The Tim is asking, besides geometry cleaning type, are there computational accuracy benefits of SimScale over BlueCFD? Yes and no, I would say. So the nice thing with SimScale again is it's highly automated, and they serve multiple businesses, but a big chunk is the AEC. So they've made it quite easy to run. It's a transient solver, so you actually have fluctuating wind. We do need to, we're talking with them. So I showed you the turbulent inlet condition. We're actually talking at the moment with them to get that implemented on the platform as well, to have even more accurate structural wind loading. But I think it's easier because the LBM solver runs on GPU solvers. It's actually lightning fast with much more resolution. Like you can run easily 30-40 million cells, where the BlueCFD/OpenFOAM that runs, typically you want to run RANS, Reynolds average Navier-Stokes, the steady state simulations. They're still good. You can still use them for pedestrian wind comfort. I wouldn't really use them for structural loading. But typically if you run that locally on your machine with BlueCFD, you're just running it on your laptop, right? Your 2-core, 4-core machine. On the GPU, on the cloud, that's a whole different league. You're basically, I think you're running equal computations that you would run on Nuada.CFD for maybe a week. You run it easily in 2 hours on the cloud. So it's more actually the speed of computation, your quick hours. And we'll see that in a second. Because if I start a low resolution run, I think it's actually only 45 minutes or so. So I'll go through this relatively quick because we actually got a live demo coming up. Let's say we'll install the app and I'll show you. So basically you can launch, hold on, there was one more comment. So paid by project or by each simulation. So you pay actually by minutes that you run your simulation. And historically SimScale had a license agreement where you pay for the seed and then you pay for your usage. With the app, what we're trying now is an actual true pay-as-you-go system. So you press run in the app and you get charged for that project for these minutes that you run the simulation. We have to try that out in the next few months, how that really works, but that's the idea, that you don't really have to, as a new customer, don't really have to set up a big corporate license agreement, but you just run it from the app with a few clicks almost, you're set up. Again, it's beta version, so that's the part we're figuring out at the moment. But before the end of the year, we really want to have that set up. Right, so let's dive in. So you launch Nuada through the command Nuada.CFD on the command line, and then you get presented with this kind of home page. So these are your projects. So these projects are all tiles you can go in and visualize. But actually, what we want to do is press on the plus on the top and launch a new project. So basically, you put in a bit of information, your project name, project number. So for instance, the project number, we use that internally to then charge that amount of money to the project. And then it's up to the project team whether they charge it back to the client, yes or no. You go in, you press load layers from Rhino. So you see that's the connection with the layer structure in Rhino. We'll see that when we go through. So you got your proposed existing context. And from there, so the app picks that up. From there, you can then say import geometry and you continue to, okay, we'll go to the next slide, are we? So I put a few stops in those videos. We choose for a proposed simulation. So you can choose either proposed or existing. I'll get to that when we get in. So there's a few screens really to go through. So you set your low, medium, high res resolution, choose pedestrian comfort, and then you right away can choose, I want 16 or 36 directions. You got to load in a climate file. This is the part that we still want to automate a bit more. So you load your windrows, basically your local climate. You set your terrain conditions. So this is the approach flow. And you can either set it for all 16 directions at once or individually. So for instance, if you're, say, in Miami on the coast, or here in New York, you're on the Hudson River on one side and you're building your build-up mass on the other side, you clearly have two very strong, different approach flows. Sorry, I'm skipping through. We're going through a few more screens. I'll take it more easy with the live demo. But you see a few more screens saying where you want comfort results. Because the one thing with SimScale is that because it's running on the GPU hour, they don't really save anything after the simulation. So you need to preset where you want results, on which colored planes, on which roof terraces, etc. So those were those 3-4 screens. But now we're done, right? So you can literally press, looks good, start the simulation. And what it does then is, I'm trying to press, yeah, page down, okay. It starts to package the simulation, the geometry and all of the settings up locally on your machine, pushes it up through the cloud, through the API. And start your simulation. You then get, do I have it coming in the next slide? Once that's done, you get a prompt back in the app. So you're still not charged for the project. So you get a prompt back. So this, for instance, runs for 170 minutes. It will cost you 13 GPU hour in terms of credit. And when you then hit OK, that's when the simulation starts running, and you'll get charged eventually. And to give you a perspective, that 13 GPU hours, so there's a few pricing models, but typically I think that starts at 15 euros a GPU. So that's from the top of my head, what is that, $12? Am I saying that right? $11, $12 a GPU hour. So a simulation like that, so that's a medium resolution, quite a large domain for this 16 directions. That would be $140, $150 to run. But it's literally taking you half an hour to prepare, and then, as you saw, 2-3 minutes to get it running. So I think personally that's quite appealing, and it's worth the pay. But I'll let you decide for that yourself. I'm going to skip through this, but if you go for the second option, I call it structural loading. Maybe we should name that differently, but you can then get this prompt and you can choose individual directions to run and basically look at base shears and pressure on the facade. The rest is all the same, so I'm going to skip through this. But you get the gist of this. The other mode of the app is actually getting results back into Rhino. So after the simulation is done, you can go into one of those tiles, for instance, at PWC, so that pedestrian wind comfort demo. You can choose which results you want to get to. And as I said, this is the part we're actively working on. So we need to prettify this a little bit. But the statistical result, that's your pedestrian comfort. You get prompted to download it, and you can press visualize. And you can see in your Rhino viewport. So this is pedestrian comfort on the ground level, plus the buildings. There's also in the app, because this should actually show you a pull-down menu of the comfort value that you're looking at. I think in the next one, yeah, that's how it should look like. So we need to check what's happening there. But you can choose your pedestrian comfort criteria. So you can easily flip between a Davenport, which is more used in Canada compared to a Lawson in the UK, etc. Few things we're still working out here. So at the moment, this is only previewed geometry, as if it would be a grasshopper geometry. So first thing we need to implement in the next few weeks is a bake button, like that you can actually get these meshes out and do something with it. Also, we still don't have a legend and change of color. So that part is still in the works. I think in the next 2 weeks, we'll have an update on that, and I'll let you know. But basically, yeah, we get the results back in. So that's pretty exciting. And that really becomes a communication tool within your Rhino model. You can also choose some other directions. So I'm going to go here to, for instance, that 202. So that's southwest. And for those results, we also have a horizontal surface. But this is not aggregated comfort. This is an individual direction. And if I go to the next one, so that's what I mean. Like we need to group them a little bit more, because there's additional results. SimScale, when you download it, it groups them a little bit funny. So we need to group them in differently in the app, I think. But the additional results that have takes a little minute. This is a transient result. So this is a lot of data by downloading it, but you get a vertical plane. And as you see, if you download a transient result, you actually get these buttons, the play button, the forward, backward. So you can actually loop through time. Again, it's a little bit jittery still, but we'll get there soon. And because you're looking at an individual direction, you can actually look at velocity going through the domain, but also pressures, etc. And if you had set, say, pressure extraction on the buildings, you can see that as well. Right, so that's it in a nutshell. So just to summarize, really what we're trying to do is get in early, and when everything is digital, when everything is easy to change, let's run quick simulations. And sorry, I see this applied at a few different stages in projects actually. So when it's early on, and I'm really talking early concept, you have a general idea of sorry, I'm trying to prepare. If you have a general idea of masking, but not very refined, you can run quite coarse simulations, and they're maybe $20, $30, $40 each, right? Like they're pretty cheap. You run them in half an hour, 45 minutes, and you get an instant result. Then when you go, say, into early SD, it becomes a bit more firm. You want to run almost like a medium resolution. So you maybe run those $100, $150 runs. But then when you go forward and basically do pedestrian comfortable planning or something, that's when you can run a more detailed one. They might cost $200, $300. But at that point, that's the moment that you perhaps go back to a client, an owner, developer, and say, wait a minute, maybe we can do this, but we might need a bit of fee for that. Or we actually increase the scope, let's say. The other nice thing with SimScale is, so as Thornton Tomasetti, we have 5 user accounts. You can actually share projects between accounts, and that's something we'd like to put into the app soon as well. So within your team, but even say if we would be working together as an architect engineer connection, we could share models between ourselves and actually work together in it. And basically, perhaps you set it up first, and then we take it over and add something in terms of structural loading, use it in our post-processing routines, for instance, and get stuff in. And that's what I quite like about that. As I said, you can use it now, so it's not really publicly available yet because we're still in beta, but I'm happy to share it with you guys. It will be probably soon on Food for Rhino and all the places with a landing page and some documentation, which is also still in the works. And again, it is work in progress. So please give us feedback. Anything you like, you don't like, you think it's missing, drop us an email, get in touch, and we'll work it out. Basically, it's active development at the moment. So that's it from the presentation point of view. I don't know if you have any questions at this point, or want to know more, or should repeat anything. So please feel free to shout. If not, there's going to be plenty of time still left. That's fine. I would say let's have a little coffee break. Let's stretch the legs a little bit. We can be back in, I don't know, 11, something like that, 11. Let's do 11. I'll drop the files in the Google Drive, and I'll share it here in the Zoom chat, the link to it. So then we'll stop the presentation, and we'll actually go and get our hands dirty, make sure that everyone has the software installed, and then we'll go through an example and check it. So it's 85 now. Let's say 10 past. Let's be back at 10 past, if that's all right. And then we'll continue. All right. Right. So again, there's a Google Drive link in the chat of this Zoom meeting. It's the same one as that's been emailed to you a few days ago. Let me share my screen again. And that should look like the following. So you got a zip file, Nuada.CFD. So that's the whole plugin package. I've dropped in a sample Rhino file. a little text file with the API key. You'll need that when we run the app the first time, and a bit of weather data for Newark, New Jersey, and I've done one from London Heathrow. We'll get to that. As I said, we want to automate that more, but this is where we're at now. So if you download that, that should look like that. One thing I always do with these zip files, because there's a bunch of DLLs in there. Now I think it doesn't show up for me, but if you download it and you go to right click and press properties, you probably see some in this bottom white area. You can probably unblock the zip file. I'd recommend you to do that before now. Actually, let me just download download it and I'll show you. That's a new thing of Windows 10 basically. So if I go to my downloads. So that's the Nuada.CFD. If I right click on that one and say properties, there you go. You see it's the security warning here. I'd recommend to unblock that file, because if you do this on the zip file first before unzipping it, it will actually apply to all of the DLLs inside of it. Otherwise, you'll have to do that one by one for, and I think there's 90 files in there or something. It's quite a few dependencies. Click apply and okay, and that removes that. So in terms of installations, what you need is Rhino 6 or 7. It should work on both. I've been mostly using it in Rhino 7, so that's the safest bet. So let me go back to that folder. So you can basically, I would recommend to unzip it in a folder and then move that folder somewhere outside of your downloads. So doesn't really matter where it is. I have it in, let me browse to it. I have it under my user folders, program data. I think it's a TT folder, Thornton Tomasetti, core, Rhinoceros 6, Rhino.CFD. No, that's the old one. Nuada.CFD. So that's. Let me just drop that in the chat. If people want to use that file path, that's fine. You don't have to. I would just recommend to move it outside of the downloads. So this should look like this. It's 94 items. And basically, in terms of installation, what we're going to do is this core.cfd.rhinoceros.rhp. That's the Rhino plugin. We're going to drag and drop that into the Rhino viewport. So wherever you have saved that, that's the location Rhino associates the plugin with. So that's why I'm saying move it outside of the downloads folder and drop it in Rhino. So then we can launch Rhino. We're working on the side as well as Core Studio. We're working on a deployment package for all of our packages called Core Drop. We've just launched that internally within TT. And the idea is it's also going to work for the external app. So soon enough, that's pretty well done, let's say, but soon enough that will be available for everyone as well. So that will probably be the deployment platform. So you can find the plugin probably on Food for Rhino, but then it kind of links to that platform. Or we'll figure that out, but that's where we're going. So basically what you do is, let me minimize that a little bit. Make that smaller. So you literally grab that .rhp file, and it has that little Rhino puzzle icon and drag it. You see the plus there, and you drop it in Rhino. So in this case, I already have it installed, so I get this message, ID already in use. If not, it will go through a few lines on your command line, and it will install the plugin, and you're done. That's the installation. And then you can run Nuada.CFD, and that will pop up the plugin. I think it does, no? What's happening? I've been messing around a little bit with extra screens, so maybe where's my plugin gone? Interesting. So long for live demos, I guess. I'm gonna restart Rhino again and see what that does. I've been plugging the machine into a docking station with extra screens, which does it still think it has 2 screens attached? Right, let's try that again. Yeah, there we go. So then you should see a window like this. All right, let me pause a little bit there and see if anyone has a problem. So Per is asking, should Rhino's 7.0 folder perhaps? Actually, it doesn't really matter, because I know all of the plugins actually still live in a 6.0 folder, which is really strange, let's say, but they haven't really ported it over as a new 7 folder. I think all of the 6 plugins should work for 7, etc. So that doesn't really matter. So just double checking if everyone got to this point. That should be good. All right. So the login, that's also something that's still on the books. It's not really doing anything. So I'm just going to press login, and now we're going to see a different screen. So I'll get back to that in a second. So I'm now seeing, because this is my API account with SimScale, I see a lot of projects here. You'll probably get prompted for an API key. So let me restart this for a second. I'm gonna stop share for a second, because I don't want this to be on the recording. Let me delete my environment variables for the API key. And so I'm just going to delete that one and delete that one. And then I'm going to run Rhino again. So, and that API key, so I've pressed Rhino, loading Rhino again. That API key is stored in your user environment variables. But the first time you launch the app, you need to provide it to the app, and then it stores it. So the second time, as you saw, you can just log in. So if I do Nuada.CFD now, I've just deleted those credentials. So if I now press login, you get presented with this screen. And it wants a SimScale API key and a URL. And that SimScale API key is in that folder as well. So that's this text file. And it's all over the place with the screens. So for the workshop, we've created a specific SimScale account, workshop 2 and workshop +2 at SimScale. That's the email, email and username. This API key, that is, we are sharing it now within this group, right, on this one account. There's some credits on there, so we can run some simulations now. This is the only thing that is connecting you to the SimScale account, and therefore anyone that has this code can actually run projects on your account, right? So you will be charged for that. So once you get that API key from SimScale, be careful to not share it to people you don't want to share it with. In this case, this is specific for this workshop, so we're fine. So I'm going to copy this and drop that in here. And the API URL, that's this https api.simscale.com. I'm going to drop that in here, and then I can press configure. And now I get presented with an empty project list, right? So all of a sudden you have this list. Okay, your collection of projects comes here. Create your first project. Okay, we need to make it first. I'll just stop there. Is that fine with everyone? Everyone still with me? Very good.
All good.
All good. That's what we want to hear. So I've also in the folder provided this Rhino file, and that, let me drop that in Rhino. Unfortunately, the app, that's a Rhino thing. The app will reset now. Not what I want to set anything. And within this file, so I'm going to actually go away from this pretty view and go to shaded, because then you'll see the layer structure a lot better. So as you see, the app is actually resetting to the front screen. Unfortunately, that's kind of a Rhino connection. I need to check that with my colleagues. I think we can bypass that. But basically, okay, let's log in again, and we're back in an empty project list. So I'm gonna close this for a second. So this is actually, it's already an outdated model of the City of London. There's a few buildings on which corner. I think this one is now completing. They're building another one here in this corner. So there's, and actually this one is topped out already as well. So this would be a typical model we would, an extent of dimension we would build for a proper, high-end CFD simulation. So this is the gherkin, and over the years, what I've kind of taught myself is I'll have a proposed building. So that's the building I'm studying. Typically, I want to include an existing building. So say, in this case, I just copied the same geometry, right? So it doesn't make sense. But say you have a 4 or 5 story building on site, and you're building a 100-meter tall tower back. And this is more to do with same resolution of mesh size, but also with same size of images and results out of the back. What I'm doing inside of the code, and therefore what the app is doing, is that it calculates the size of the digital wind tunnel, the size of the domain, based on the tallest building. And whether you choose a proposed or existing building, it will calculate it on the largest of the two and only run either proposed or existing, if that makes sense. So you can put in both. You can put in your 4-story building. You can put in your 100-meter tall tower, your 20-story, 30-story building. And the digital wind tunnel, and therefore the size of the mesh and the resolution, as well as how the results look like, etc., is calculated on both. So it's basically calculated on the worst, the tallest building of both. And then in the app, you can choose, I want to run a proposed, I want to run an existing. That's just me, how I taught myself in a way. And then everything that has this TT_CFD_ prefix will be picked up by the app. And the naming does, again, I'll document this. Unfortunately, that's not there yet, let's say, but the naming comes quite precise. So proposed and existing, it kind of means something. It's a category. Context is a category of the surrounding buildings. And then you have a category of ground. So that's either your ground around the site or within. And typically what I do is I split them out. So I have a general ground. So that's, I model it big enough so that it, especially when you have topography, that it kind of intersects at, it's bigger than the domain size that you're going to get. And what's the domain size, you ask? I typically do this 1.5 to 2 kilometers so that I'm for sure know it's long enough. So in this case, this is 4x4 or something, I think. Oh, even bigger, 10 kilometers. So this is really big. Typically, you don't have to go that big, to be honest, but better be safe than sorry. Because this is ground, and we'll see this in a bit, this gets this ground roughness attached to it automatically. So whether you set city or urban or suburban or open terrain, that is get attached per direction to this ground plane. That, so I'm going a little bit into detail here, and I'm happy to share papers and stuff if people are interested in more detail there. That is sort of a representative average height of buildings. It's called the atmospheric boundary roughness length. So for urban terrain, that would be 0.8 meter, let's say. If you're actually building, modeling the buildings to a certain level of details, and it's not that deep, right? You see they're relatively simple extrusions. So I'd say a step size of 30, 50 centimeters, so what, 1-2 foot. That's the type of thing I typically include in the surrounding buildings. The building itself typically is a bit more detailed. But with those buildings modeled, it doesn't make sense to attach that atmospheric roughness to the ground surface within that, because you've covered that already. So most of the times I split it up into 2 ground surfaces, and the one in the middle, that's called ground_explicit. Okay, that was a big information dump probably. So let's pause there for a second. I think I have a question as well. Is there a rule of thumb for modeling these ground sizes? Yeah, there is. So if you want to run a proper CFD simulation in terms of high resolution, then it's all driven by the size of the wind tunnel. And that's all driven by the tallest building in your domain. So in this case, it's the 22 Bishopsgate. And it basically takes, if you want to do it properly, you take the height of that building times 6 is the height of your domain. I'm also using that as the inlet plane. So if your wind shape comes from the left, it's also from the center of the building 6 times that value, 6 times that reference height. That's where your inlet plane is. For the outlet, it actually needs more than that. It needs to be longer. So you kind of want to have that 10 to 12 times that height. So that's where it comes in. That's probably on a building this size. So this is about 300 meters. That inlet plane is in the range of 1,000, like a kilometer and a half, if you really want to do a full res simulation. And it's even almost 3 kilometers away behind the building. But then that 3 kilometers rotates around, right? And the tunnel has a width. The width, not really set, but I typically take as well that 6 times the height as the full width of the tunnel, rule of thumb. So that spins around. So that's a bit more than 3 kilometers of radius. So 2 miles of radius. That's kind of what you need. So it's the size of that building, and there's a blockage ratio, because basically what you want to do is you don't want to block too much of the airflow so that you artificially squeeze the flow between the buildings and the size of your tunnel or the top of your tunnel. Because it's still a physical boundary. The CFD simulation takes that into account, that is actually an infinite size, but it's still a wall, let's say. So you need to avoid that they're too close. If we're going into the low res and the medium res, to be honest, we're squeezing it a little bit. We're going down to 3 times that height. So the tunnel becomes smaller. But that's sort of the range. And again, the number of buildings you need to include, that's a similar thing. I typically do 1 to 1.5 times that height, unless there is some tall buildings that still could influence the wind, then you do include it. That makes sense. Does the layers have to have the exact names in the provided model? That is a really good question. So yes and no. So we're still going through it. I think at the moment we're too strict, and it's not user-friendly enough, I think. So you need a proposed or an existing, one of the two. You need a context. No, you don't need a context, but you need, and you actually don't need a ground. You definitely need a proposed or an existing. You don't need the others. However, they do, based on the name, do different things. So with the underscore, you can add multiple things to it. Like that fourth term, sorry, that can be anything you like. So, and I want to show you as well. I want to put some roof terraces in under proposed. It's not going to be on the building, but we'll gloss over that. So yes, it does make it. It does come quite precise. So what I'm going to do with that, let's go back into the app. So I closed it. So I'm going to launch it again and press the plus button. Let's make our first building, our first project. I'm going to elongate that a little bit. So I'm going to name this City of London. And if you're following along, you're very welcome to. I would actually recommend put your name in here, because we're all working on the same account now, right? So we're going to have 12 projects showing up there all of a sudden. So if you do something yourself, you might want to put your name on there. It will still make those 12 projects, even if they have the same name. But let's say in an hour or so, or tomorrow, we won't know which one is which, right? So I'm just going to put a dummy project number because it doesn't make sense now. Description can be anything, to be honest. So I'm just say wind around the Gherkin, and the location. At this point, it doesn't do anything. Well, idea is, and that's one of the next steps in the coming 2-3 weeks, is to actually make this automatically read the climate data. So we got an API with MeteoBlue. SimScale has enabled that now to automatically read the weather data in. That's not there yet, so we'll see how we do that in a second. So basically, you populate these 4 fields. I mean, it's just text-based, so there's no check, but you need to fill them all in. And we go to create project. Now there's 9 or 10 windows we go through them now, and let's go through them one by one. So if I press load layers from Rhino, and by the way, if you have any questions or anything, or if it goes too quick, just give me a shout and we'll stop and we'll make sure that everyone follows, right? So I pressed the load layers from Rhino, and you see that it picked up the proposed, the existing, the context, ground explicit, and ground. That's great. So we want to include all of them. So this include is also, you want to include both proposed and existing. As I said, it's calculating the size of the tunnel based on that and some other options. You then choose either a proposed or an existing. We go for proposed, doesn't make difference in this case. And if you have any trees, however, I should really remove this. This is not implemented yet. So through SimScale, you can also put in trees. Again, one of the first things we'll add. And basically we set up some generic leaf area density. So in summer, trees are much denser than in winter. It gives you a little bit, you need to think about it, how you do it with annual comfort. That doesn't really hold, but anyway, you could put it in. But actually, let me edit something in this model first before we continue, because as I said in the introduction in the presentation, you need to set your areas and surfaces of results first in the app before you start running it. That's just a thing of SimScale. So let's say I want to extract a few of those roof terraces for results as well. Let's say on this building and the roof terraces on this building. So what I'm going to do here in Rhino, I'm actually going to create a new sublayer here. And I'm going to call that TTCFD underscore. It's on the context building. So let me call that context roof terraces. Enter. Right. So what I've basically done there is it's the prefix TT underscore CFD underscore that will make it read in a second if I press refresh in the app. Then I use the context group. I could also have used the proposed if I have some on the building, but I don't. And an underscore roof terraces, that could be anything. Let me give that kind of a funky color. I never choose yellow or green because I mean, I'm colorblind, so yellow for sure, but it's too close to the select color, so I never use that in real life. But let's use some lavender or something. And I'm going to make that the active layer by clicking in this column here of current layer. And what I'm going to do is deselect. Let me hide that. Hide the app for a second. I'm going to extract SRF. Enter. And I'm going to drop it into the current layer as an option. And I'm going to turn copy off. So I'm not duplicating surfaces, but I want that one. And I want these roof terraces here, for instance. Because that's what I'd like to do now is to extract comfort values on these roof terraces. I'm going to hit enter. You see they turn blue now. So they're in the roof terraces layer. So that's fine. I'm going to test. And you see that these surfaces are now open, which is fine. Our app will deal with that. Closed surfaces work slightly better typically in terms of running the CFD, but actually SimScale, the geometry is so gentle that it can, and the app preprocessor, it can actually handle that. So with that little edit, let me actually just save that. Oh, this is a Rhino 6 model, I think. Isn't it that? I think so. Yeah, you see, I'm going to save it as Rhino 7. That's fine. So I pulled out a few roof terraces, and then if I press refresh layers here, you can see it now picked up that context roof terraces, and we're going to use that in the next screen to extract comfort on those roof terraces. Is that okay for everyone? If we want to do it again, I'm happy to repeat.
No, that makes sense. And now because it's a part of context, I guess it's included both as context and analysis surface, right? Exactly.
And the thing it works is the proposed building, let's say, or existing, it also gets an extra mesh refinement attached. So that's also how these categories work in the app pre-processor, let's say. That's why these categories do make sense. but we're thinking of, so any comments or suggestions are welcome. We're thinking of making it more generic, let's say, so that it doesn't need to be proposed, but it could be, I don't know, the name of your building, right, or something like that. All right, so with that, let's continue. Let's press import geometry. So there's only a few screens to go, to be honest. I mean, it might look daunting at the beginning, but actually it's not really. So we can go for simulation fineness. So you can run it at low, like a quick and dirty early stage simulation. It's still fairly okay, actually. Medium, or you want to go high, fully fledged. But I think these are quite big and expensive. We might need a bit more refinement, but I'm going to go for low, just a simple, quickest. And then you choose either pedestrian wind comfort or call it structural loading, but it should actually be a single direction run. So let's go for pedestrian wind comfort first. Let's check that out. Press continue. So it asks you how many directions do you want to run it, 16 or 36. Now the trick here is that you need to import weather data. That already also needs to be processed by the number of directions. So in this case, the weather files that are provided, I'll open them in a second, they're all 16 directions. The comfort criteria to report, really this is a switch between the City of London criteria and Lawson, because the City of London, actually we should do it here, but I'm not going to do it. The City of London has a specific microclimate guideline. Actually, let me make a note. I'll share that afterwards. Because it also gives you some information, some background information. But what it does is it also, for planning, it prescribes weather data, it prescribes parameters of mesh resolution, etc. So it really levels the playing field, which is really great. And quite a few cities now are like Leeds and others are following that example. Because it's so specific, it has an actual different module in SimScale to run. So it's runs slightly different than the generic pedestrian comfort. That's why this switches here. The others, you can actually freely change. So I'm just going to go with Lawson LDDC.
Is there a way to figure out whether the EPW is 16 or 32, or you just know that?
You just know that. And it's also not actually the EPW. So I've written some of my own routines in little Python scripts that so we downloaded from Iowa State University. Again, I'm gonna share all these links in a second with you in that Google Drive. But basically, this Iowa State University database is really good, purely on wind, right? It's international. So say, okay, you're in Sweden, right? So I want to go to the Sweden network, switch network, and then actually on the map, so you have quite a few weather files. So for instance, I want to go to Stockholm, so you can actually look at Stockholm proper, but as well Arlanda Airport. So you see it has data from 1977 on. The one here actually even older, 1931. Go select station. The tricky bit is this is a local airport with already urban area around it. So I'd rather use the airport often. But you can look into the windrows, how that looks like. So that's your annual weather data. And I think this is relatively a lot of calm weather because it's probably in an urban environment. And they split it out per month. And usually what I then do is I go to download. And for some reason, you need to choose it again. I don't get that, but you choose it to selected stations. And then on the right-hand side, you can give it your time range. And that I always do that, save results data to file. And then you basically get data, you get a massive text file of all of that raw data. So this is measured data at the airport for typically every half an hour. right? But this is a great source. I'm using that, and then I have a little Python script written myself over the time that then converts this into a pre-packaged stat file. So if I go in here, so these are on the Google Drive as well. So I gave the London and the Newark airport. So for instance, that annual file, okay, sorry. I'll open it with Notepad 2. If you have Notepad 2, I highly recommend it. It can open almost any text file. So this is the part that we still really want to automate as first, right? Because basically what I'm pre-processing the weather data into directions. So every line is one of those 16 directions. And then it's binned into how much percentage is below 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, etc. And then the total is 6.5% for that direction, 5% for that direction, etc. again. So yeah, this part is still a little bit clunky. Apologize for that, but basically it uses this, it outputs this windrows. I might actually drop the Python file later into the taking notes what I'm promising to drop in there.
But standard is to choose 16 rather than 32 for most EPW.
Yeah, to be honest, 36. So the City of London prescribes 36. You have to run 36. You can run 32, 24, but to be honest, 16 is often fine enough for what you need. I wouldn't really recommend going lower. So there is also some solvers that actually SimScale does it as well. You can choose 4 or 8. 4 is too crude in my opinion. Like you don't get the nuance. Like basically 4 is that quarter is one probability. This quarter is one probability. I mean, that's too crude. Even 8, I would say, is too crude. You don't find the flow around specific corners that you might want to. And then if you aggregate that to a yearly comfort, in my opinion, it's too crude, but sometimes you can get away with it, let's say. Not for planning though, not if you go into the detail, then definitely 16 or even more. Is it because the EPW's files are not accurate? Yes and no. Most of them are actually relatively fine. The thing with EPW files, what I would say is they represent a year, right? So you have 8,760 values for every hour of the year. And it's sort of a model year. So it's still wind data of 10 years or 20 years. But they pick individual days to make up the weather file. The stuff that we download from the Iowa State University, that is actually the full 30 or 40 years of data, literally measured every hour or every half hour. You have all of that data. So I think statistically, that is a better representation. The other thing as well is it still needs to be pre-packaged so that SimScale knows how to deal with it, let's say. So I might write an EPW reader as well, probably. That's probably the easiest one. And as SimScale is working together with Meteor Blue. So Meteor Blue is weather and they have an API. So basically with that API, you can tell them a location or a longitude, latitude, and it will tell you, you will get annual weather data. So that's what I want to connect to, so that in that first field where you say, in this case, we said London, UK, that is picking up the weather file. We haven't gotten there yet. We're a little bit behind with YAP as where we wanted to be. So at this point, we're loading, we're clicking on that button. Also, if you don't know that wind data, you can't continue. We block that because it's pretty critical for the patient comfort. So if I click on the load wind data, I can go into where did I save that folder? In core and the workshop. So for instance, if I want London annual, so you can choose seasonal data as well if you want to. Let's go for annual. Open that stat file. There's a little bit of pre-processing happening and checking if that file format is correct and it matches these 16 directions. But you see the error message disappearing and the continue button is now actually free to use. So now I can click on continue and it actually proceeds. So one quite important aspect to set is your terrain conditions. So this is really approach flow. So this is wind coming in from far afield, and you need to tell it what type of terrain is it. Is it an open terrain, types of sea? Is it a small town? So that's there is definitions for it. And I think the Eurocode in terms of exposure categories, or the AECE, the structural code prescribes it. In general, in terms of wind engineering, a small town is like small buildings, small villages, but then also big open spaces. A town, that's more your suburban areas. So the outskirts of London, outskirts of a city. The city, that would apply for literally this area. And we've included an extreme dense because we've been doing some projects in Manhattan, for instance, where actually city is not even dense enough. We can choose city here because actually this is a little bit of eyeballing, to be honest, to decide this. So let me go to London. Okay. So we're here in the east, in the city of London at the moment with our project, right? So the Gherkin is literally here, 30 St. Mary's X. And that approach flow, that's kind of approaching a few kilometers length. So the river is too small, that doesn't count in this case. But it's very much built up, especially if you go to satellite view, you see it's very much built up. These open areas, they're too far away, they don't really count, the parks, Hampstead Heath or so. So in this case, we can consider city all the way around. But let's say you're on a shoreline like downtown Miami, I don't know, Chicago with Lake Michigan in front, something like that. Then you clearly have an east-west divide. So in that case, I recommend to tick this box and actually set them per direction. And these directions, 0 is wind coming in from the north, and then the rotation goes clockwise. So 90 degrees from the east, 180 is south, 270 is west, and 0 is north again. In this case, we don't have to, so we're gonna take that off. We can choose city. But this is quite an important setting because over an open terrain, the wind actually comes in faster than it does over a city. It's retarded, it's slowed down more over urban terrain than it is over open terrain or water. That's that, and I have a few research papers that I'm happy to share actually after this, if you're interested and want to read a little bit more about that sort of stuff. We're going with city, so I'll press continue. And this is why I put these roof terraces in. So this is setting up which surfaces you want results from, right? So this is, you need to set this now in these windows, otherwise you won't have any results. So, and what it does is it picks the surface, it picks the results of that surface, and it elevates them 1.5 meter height. So that's your, basically your head height. your eye height type of thing. I'm going to tick on the roof terraces in this case, because I want to also not just ground explicit. So again, this is an automatic thing we've set in the app. If it sees a ground underscore explicit, so that's how I named it, this dark gray surface, it automatically populates that to extract comfort values. Them on the roof terrace, so that's up here and up here. And the region of interest, that's basically creating a diameter, no, sorry, a radius around the building of where do I have the maximum extraction of results. By default, it's 300. Often that's fine. You could change that slightly bigger if you want more detail. One more question. Any no fixes if it crashes right after choosing the simulation type? No.
Yeah, sorry, it's just crashing.
That's fine. Do you want to share the screen perhaps quickly? Otherwise, we'll do it afterwards.
Yeah, maybe we can just do it afterwards. I mean, I'm
Okay.
not doing anything special, so
that's fine. Let me continue then, and then we'll get back to you in a second.
yeah, sure. Thanks.
The thing is, it might be a lot of things, so it's yeah, we'll get there. Right. So that's the comfort value. So I want results in this case from the ground explicit, and my context roof terraces, those surfaces that we just extracted. So we'll press continue. I'm thinking maybe for pleasant comfort, I want to hide these even and only bring them up for structural loading. Basically, what this means is you can directly extract forces and moments. So this is really structural engineering around a building, right? So this is base shears that structural engineers will need for calculating wind loading, etc. Moments, overturning moments around the base. So you can turn this on and propose, and you might want to select a specific origin to calculate it around. Otherwise, it's the center point. I'm going to skip over this now. Also, we need to fix visualization on that part. Yeah, let's say. Similarly, if you want to extract surface results, so this is more thinking about pressures on the facade, that type of thing. So you can actually extract results. In this case, I'm going to turn it on, actually, on proposed, where you can choose whether you want transient results or averaged. I'll go for the time average results because it's just lighter to save and that sort of things. But you can actually, for every time step, save it, and with that, make some videos or stuff and actually look at the results over time. Right, I'm going to press continue. And with that, we're actually already at, I think it's the last screen. So a bit more to extract. So if I typically like to turn them on. So these are vertical planes through the middle of the building, along the wind. Across wind doesn't do much, actually. I have it, but it doesn't tell much because the wind flows perpendicular. And you can, if you want to, have horizontal planes. And you can add, okay, I want to have it, let's 1.5 meter and 15 meters perhaps as well. So you get 2 horizontal cuts all the way through. Again, I'm just going to do this for the average results, but you could, if you wish, do it for the transient results as well. I'm going to press finish and review. So you get one summary finally, like, okay, so you can go through the settings. Are you happy with everything? If not, you can still go back and actually update that. But in this case, we're fine with this. And I'm going to hit start simulation. And at this point, what it's doing is it's packaging this, the geometry, all of the settings, saving it temporarily to your disk, and then connecting it through the API to SimScale and actually uploading the simulation, preparing the simulation up on the cloud, starting to run. And let me show you. Yeah.
So I was just wondering, for the analysis radius that we chose a couple of steps back, is there a way to let it understand that itself, just based on the explicit ground? It makes a containing box, and does the radius for the circle based on that instead?
It could, but It's not really a strict, it's more a strict boundary of where do you want results from, let's say. Yeah, we could do that. The thing is that the ground surface typically is varying so much that I tend to not do it and just set that larger than the ground anyway, in a way. Because we're not extracting the beyond ground explicit anyway, because we're not extracting comfort results for the ground. So you'll see that it actually often just stops already at the boundary. Yeah, it's a choice, I guess. Right, so now it's done, it's prepared, it's created a simulation on SimScale. And it tells us now this is basically going to run for 43 minutes. So we're actually going to have results of this before the end of the workshop. And it's going to cost you 3 GPU hours. So if it would be the base price, it would be what, like 45 euros. So that's just under $40. I'm saying that right? So that's not bad at all for a quick 16 direction run. And you haven't been charged up until this point. If I hit OK, which I'm going to do now, that's the point when it actually initiates the run on SimScale. And now we will be charged, not in this account because we're having some free credits, but typically, yeah, this will run. And in the end, at the end of the month or something, it will be charged. You can close the window now, like there's no active link anymore necessary with the platform. And actually the progress bar doesn't really do much, unfortunately. That's the one thing we also need to update, but basically after 45 minutes we'll have results. So I can close this now, go back to like this button kind of is a home button, click, and there you go. So you see we got a couple of projects here now. There's a text overlay that didn't really well. So 5 people hit go. This one is mine. Why does it say J. Jansen API? Interesting. It should say something else. Maybe I hard coded that name. So yeah, in less than an hour, we'll have some results. I can go back to my account to show some of the visualization now. But that's basically running a simulation. Let me see what the question is here. How do you calculate the estimate cost? So that's on the SimScale side, actually. So they have an algorithm running. So part of preparing that case is that they do an estimate. So they estimate based on the settings you set, the size of wind tunnel, etc. They estimate, have a little machine learning algorithm running, estimate how many cells, how many mesh cells this will be, and therefore how long it runs on GPU hours. And it's pretty accurate, actually. It's getting better and better. And I'm just prompting through the API SimScale that estimator and gives an answer back, basically. Also, when you do hit into, while it starts running cases, let's say, if you hit into problems, what it actually does in the background is if you go into my documents, you probably have a folder TT Bioclimatic now. And in there, you're going to have a folder with the date of the day and a long code like this. Open that folder. That's where you see you'll have geometry. So that's the package geometry. The merged geometry.zip, that's the actual one that is being uploaded to SimScale. ABL inlet, that's the inlet conditions that it uses for those 16 directions. So that's your wind profile. There is a case compile. That's what we use internally as our settings. I'm going to shrink the size because it's ridiculously big because we're saving the geometry and I think we don't have to. And you'll have this log text file, which basically connects. This is the logger connecting to SimScale. So you'll see simulation run in progress, and you'll go through the steps. It's successfully read, And then at some point you see it comes back with an estimation, back to your question. So this is 43 minutes, 3 GPU hours. It estimates that this simulation is 5 million cells. And then simulation estimation. So actually, this is still live, your simulation. So we're 10% in now. So this keeps it going actually, while the app might be silent, but it still keeps on running this. So you should see at some point, probably it's also at 10% for yourselves. And yeah, we can close this and open it again in a few minutes to see where it goes. Right. Any more questions on that? Setting up the simulations, etc. Thomas, do you want to perhaps have a quick look at your error there, or what happens?
Yeah, sure. Well, I don't know.
Might,
I mean,
it might be a bit outside of the scope. Let's see, but let's see what it does, because
yeah, now it's not much happening after. Anyway, I can share screen as well.
Sure. You got permissions, or I think you do, right?
Yeah, let's see. No. Well, basically,
okay. No,
I open a model, and now if I click login, it crashes. So now it's even shorter than before. So there's no, maybe there's some logs or whatever. I don't know where you are.
No, I don't think so at that level, actually.
So yeah.
You just have a blank screen.
Or previously I could go through maybe the three or four first screens on the Nuada.CFD panel, and then after clicking the continue after selecting simulation type, it just Rhino just crashes. So,
Rhino crashes. Okay.
Yeah, Rhino crashes. Yeah, the whole thing. Oh well.
Interesting.
Hmm.
Okay. Yeah, it's still a beta version.
Yeah, sure.
That's the bits we need to iron out. Yeah, I don't directly know what that means. I have seen, I think that's a JSON conflict if you get a wide screen, but that's right from the beginning. So that's not this.
Yeah. Yeah, I can try to reinstall the plugin maybe, but anyway, we can maybe look into this, another day tomorrow or
Sure,
stage.
Sure. Maybe do that.
Yeah.
Don't want to bother the others too much with it.
Yeah, sure.
Sorry for that.
That's all right. We follow the lecture anyway, so it's okay.
All right, so let me double check again where we are in the simulation. Okay, so that's still at 10%. So, and as I said, so the next step is to visualize the results back in Rhino. Hold on, one more question. Is it possible to model context as mesh instead of NURBS? Yes. So the app will take NURB surfaces, meshes, and extrusions as inputs, basically. And then internally, because actually the stuff that we're uploading to SimScale is an STL mesh. So there is a step that the app will mesh it for you before saving it to disk and then uploading it. If they're closed NURBS, it's quite good. Otherwise, if they're open and too complex, I have seen that meshes work slightly better because you can control the mesh faces. Rhino not always meshes that nicely, let's say, right? And especially SCL export relatively crude. So yeah, meshes is fine, NURBS is fine, and extrusions are fine as well. So yeah, next one up, what I wanted to show is the visualization. So in this case, if I go into my project now, because it's still running, we actually won't have anything. So we got this run pedestrian comfort. So it does recognize there's a live run up there, but I actually have no results yet. So we need to come back to that later. What I think I'll do is I'll quickly switch accounts and I'll go back to my API account and show that. So let me close Rhino for a second, because I do need to reload Rhino, and I'm going to stop the share quickly. I'm going to update my environment variables with the SimScale API key. Where quickly see where I have that saved for myself. And there. All right, so that's the old one. Let's go back to not sure if this is still running, probably not. Now 15% last one. Let's go back to Rhino. So for visualizing, I actually don't need any model open because it's still preview. So that's the part that, as I said, that we're still actively working on. So I'm going to go back into Nuada. I've changed my environment variables, so I should now see. I have a lot more projects. That's why this loading now takes a bit longer. Yes, so this is all of my models that I have run. So let me go down to, I got a pedestrian wind comfort demo. Yeah, I click on that and I go inside. I have a pedestrian comfort run in there. And let me go down to the bottom where it says statistical surface solution. So that is pedestrian comfort. So, oh, I haven't downloaded this one. So I get a prompt, please download the results first. So I clicked on this download button, which pulls it off from SimScale and downloads it to your disk. I don't have an intermediate version yet, and I can press show. In this case, you see I got a mesh now, but I have it on wireframe. So if I go to shaded, that's actually when you see the color gradient. And let me turn all volumes on as well. So all volumes is all of the buildings. And you see, this is what I meant with the video as well. There's a little glitch. I'm gonna load that again. So I think if I load that for a second time, why do I need to? That's weird. So it should show a pull down menu of, that's interesting. I'm going to press the refresh button. Surface select solution. Something off with a download button, and with visualizing that comfort criteria. So you should be able to switch between different comfort criteria, but so this is, I believe it's Lawson LDDC comfort on 1.5 meter height. And you see in this case, I did not select those roof terraces, so I don't have the results here, but we will in half an hour or so, we will actually have results on these roof terraces here and that big roof as well. And you see, for instance, this tall building, 22 Bishopsgate, for people that know the situation in London, this is actually a really windy corner and there's massive canopies projecting out. So they had to do a lot for planning to get this straight. So it's nice that the app actually does pick it up, even with a, I think this is a medium resolution simulation. It does pick it up pretty well. And even this, this is slightly windier, is wind coming around that 22 Bishopsgate and coming down through the street actually. That's actually a phenomenon that I remember that planning report was describing as well, the wind tunnel test. So that's quite nice to see. The other stuff that we could look at a direction. I'm going to go to average 135. So I have downloaded this one. So again, I'll do all volumes. So this is a horizontal plot of the single direction. 135, it's a little bit glitchy, sorry for that. 135 degrees, so that is coming from south east. So that's somewhere in this direction, I believe. Yeah, so from here, from the bottom basically, and you see the flow around the buildings. You can choose velocity or pressure. The other ones are more technical, like probably don't really have to worry too much about it. Or you can, or you go to additional results. I only have transient for this direction. It's going to take a few minutes to download, probably. Dependent, or a few seconds, depending on the size. So yeah, that, as I said, this is the part we're working on. So it is a preview now. I can't really select anything. I can't bake it to actual mesh geometry. That's up for next week or the week after, really, to get that done. I'm gonna turn the volumes on again. And we're also thinking, so we have been doing a few post-processing routines to mainly combine it to structural analysis to get the overturning moments or pressures on a facade into structural analysis to compare it with like a Eurocode wind analysis. That type of thing, we need to think about how we're exporting it, but that's yeah, in the works basically. So that's pretty exciting. And this is now transient simulation. So this is a vertical cut through the domain, showing velocity. I can also show pressure. So you see the pressure distribution. As I said, colors and the legends, that's also up for the next release. But if let's go back to the start. And it's a little bit glitchy because it's kind of deleting the whole scene and then rebuilding it. But you can actually press play and it's going to loop through the timestamp. So again, it actually needs to stay in view and then reload. So a little bit of work to do there, but this actually loops through the timestamp, so you can actually start to think about videos and stuff in your Rhino viewport. And and perhaps even record a screen or automatically push out like 100 screenshots and then send it off to either a report or a little GIF maker. So that's also still on the roadmap, like automated screenshot exports, etc. Let me pause that there. I'm going to look for one if I have results, surface results, let's say. That's maybe nice to show as well. which one was that? And you see, I've been using the app quite a lot already, specifically to build the cases. This one might have results. So the Karg building is the your typical prototypical building that is often being used for validation, both for wind tunnel and CFD simulations. Yeah, average solution. I think I got pressure fields on there. Cutting plane. Yes, let me show. Actually, I could turn the Z on. And I pressed visualize. I think this is quite a detailed study, actually. There we go. So for this one, so this is, as I said, this is the prototypical one, right? So you have wind coming in from the left. There's only one building in the domain. So this is a 180 meter tall building. It has a prescribed depth and a prescribed width. And so this is your velocity around that building. I'm going to hide that cutting plane. And I think that mesh is really fine. I'm going to show pressure on the facade. So this is velocity on the facade, which doesn't make that much of sense, but we want to look at pressure. So we got a few separate post-processing routines to get this stuff into useful things for structural analysis. And that's also on the roadmap before the end of the year to kind of use this to find pressure distributions and your base moments and shears to get into structural analysis. But this is your pressure distribution, and it's pretty typical, let's say, for a building like that. High zone of pressure on that kind of 2/3 of the height, low pressures around the corners and the back. Again, we need to work on the color gradient because it's red on both sides, so that's not really helpful, because then it's relatively low at the back, which you would expect as well. So yeah, that's where we're at with the app. I don't know if there's any questions, any comments at this point, or if people are, sorry, passing you, Thomas, but if people are struggling so far, or how can I use the wind analysis results from Nuada as an input in a thermal comfort analysis? Or I can download all the analysis points and results per point, right? Yes, good question. And actually we need use cases of that, let's say, right? So we got this question actually from Tim last week as well. So when you put in the results, you can, okay, before I promise this, I need to remind myself. There is an option to put in a mesh. And what it will do there is, so when you go to, let me create a new, I need to load my model. Let me quickly load my model. And I'll show you where that is. So if you create a new project, I'm just typing something in here. Doesn't really matter. Load the layers, import geometry, dressing wind cup is fine. Pick up a wind data. So what's London? Doesn't actually make a difference. Continue. Terrain conditions, city, comfort. So forces and moments, surface results. Here there is a load mesh as pro points. Now what I'm saying is, before I promise that this works, I need to double check on my end what we're doing so far with the visualization. But this, to be honest, when you have your account on SimScale, you can always log in on the platform and actually manually download it as a backup. But so what this does is it uses the vertices of the meshes as result points, as pro points, and nothing more, right? Because these, if I get pressures on the facade, let's say, SimScale on their platform side does another meshing based on the mesh resolution of the CFD simulation. And you will get, for a building like this, it depends of your resolution, but you could easily have a mesh of 100, 200, 300,000 faces back. Very fine. You probably just want points, I don't know, every half a meter or so, right? Or every 30 centimeters, something like that, which you then also can compare with, let's say, if you do a full thermal analysis, your UTCI comfort values, right? You have points you want to compute it with. So that's where my thinking came in from here. You put in a mesh, it picks up those vertices of the mesh, so you could do a Delaunay of your points. Put that in here, and then you get results on the specific pro points. Just for a second, I just can't remember what we're doing on the visualization side if we have implemented this and the results side. Right, that's why I'm a little bit hesitant yet. But that's exactly the purpose of this, yeah.
And like the typical mesh, cell size for the analysis, how would that be? Like how big is that?
Well, that's to be honest, if I would turn this proposed on, so actually get results on that building, that's very fine actually. The SimScale goes really into the single centimeters, let's say, actually.
Right.
So often much finer than you need. So probably I would recommend to use this load meshes type of thing, so that you can control in your Grasshopper script, for instance, where you want results from, where you want to measure the UTCI.
Yeah.
And you put in this mesh, and then you'll basically get, the way it's saved is actually a CSV table. So you'll get results back for every 16 directions individually, right? So you do need to do a bit of post-processing, like when to pick which one from which direction, multiplied by which velocity. We could maybe post-process that, but yeah, that's not in there yet, let's say.
Yeah, but the data will be there.
Yes.
Yeah. All right. Yeah, thanks.
Any other further questions or comments, or something you want to go over again? That's fine as well.
Just a quick on the terrain conditions. Like,
yeah,
would it be, if you're not sure if you're gonna choose, I don't know, city or town or something, would it be best to go like a bit up, denser, or a bit down to less dense? What would be like a safe way to kind of?
Yeah, it's a bit less dense is worse, because, well, if we're talking about like climates that are not too hot, let's say, right? So less dense means that the wind is not slowed down So the wind speed is faster. And often that's less comfortable for sitting down, right?
Yeah.
So less dense would most of the times be more conservative, I would say. Right, like you quicker pick up areas of higher wind speeds, and therefore it's not that comfortable to sit down for outdoor dining or something for half an hour, that type of thing. Can you input the wind speed instead of loading from a test file? Not yet is the answer there. So we need to think about how we do this, let's say. So typically what we'd like to do is to run it at 10 meters per second, at 10 meter height. And then we can do a lot in terms of design wind speeds for structural loading in post-processing phase, right? So you would get all of your results and you can then scale that up to your, whatever it is, your 30 meters per second wind speed for a Eurocode or your 70 miles an hour for the American code, let's say, because they also multiply slightly different. The Eurocode looks at mean wind speed, whereas the AEC looks much more on peak wind speed. So there's different things in that. We've been doing some post-processing ourselves on that part. And I think we're at a point now that we've done enough of those to get back into a routine, and we could actually automate that. I think I would still kind of run the simulation at a lower wind speed because there's other things connected to that as well, even like mesh size and time of running, etc. But yes, I would definitely want to input, like, for the user to input a design wind speed so that you could actually get pressures out that are useful in your structure analysis at that point. Yeah.
Okay.
Now, good question.
Thank you.
And again, I think that's where we need to start testing and using it, right? So, as I said, we've been doing a few internal within TT, but that's where feedback is really welcome and helpful. Right, I'm going to switch SimScale accounts again. I want to see if our simulation is that still running. Probably not, because I switched accounts. Yeah, that stopped looking at it at 10 past the hour. Okay. One more question. Can you show the results of a structural loading run? So again, that's also work in progress. So let me show you one live on the SimScale platform, just to give you a feel of what we've been doing there on literally last week with our team in LA. So simscale.com. Go to dashboard. So now I'm actually logging in, say, the traditional way into the SimScale platform. So it's all online, it's all on this dashboard, and you got your projects there. So for instance, here we would have a tower that is, I've got a simulation run. Actually, let me not show the low wind speed. So we've used the pedestrian wind comfort to run it in 16 directions, but then we've actually, 0 is probably the worst. Additional average results. So you would get a pressure distribution like so. There we go. So this is wind coming in from this face. So you have the highest peak up here, lower pressure on the back. These are measured in pascals, but this is pascals. This is pressure based on that 10 meter per second wind simulation. So we would need to first bring that to a pressure coefficient and multiply that up to the wind speed. Actually, in this case, what we've used is these forces and moments. So SimScale gives us a table straight away of force in X, Y, and Z. I mean, Z doesn't mean much in a building typically, and your base moments around X, Y, and Z. So again, these are based on the 10 meter per second. So what we've done is in Excel, where did I save this? I think on my, yeah. So on this one, so I downloaded all of these and we've, so again, this is hot off the press, right? We've been literally doing this last week. So we've basically took all of those, you recognize that from the online platform, right? So this is force XYZ, moment XYZ. We then did some multiplications to go down to a pressure coefficient type of thing. So normalize it and then multiply it up with the design wind speed. In this case, it was Eurocode. So it's an average hourly mean wind speed of 33 meters per second. It's still also measured at 10 meter height. That's how the Eurocode does it. And then we've basically put that in this graph for all of the 16 directions. And basically the worst one was the force in Y direction in this case. So that was 46,000 kilonewtons, which was, from the top of my head, about 70 or 80% of the load we were expecting from code. So it's kind of similar magnitude to what you would expect to come back from a wind tunnel test, actually. And this is still early stage project, let's say. It might even still be a prospective project, to be honest. So yeah, it's just great. And this took, I mean, we had a few iterations in terms of figuring this out, but the simulations took a few hours, like 2-3 hours. And then this post-processing another 1 or 2 hours. So yeah, half a day, we got this basically. And now I think we have this as a routine. I'm quite confident to now just next simulation, drop in these numbers again, right? And we can get that table in like almost half an hour, or something like that.
Okay.
So yeah, this is manual in Excel. We'll get that into the whole app routine probably soon. That's the idea.
Okay. Thank you so much.
No, that's fine. Thank you for the question. I mean, this is the great stuff. I want to go back to our simulation that we've just run. So let me one more time change my account here. SimScale API key. So I need to use that one. It's not that I'm hiding too much, but at the same time it is, because we most likely going to put this recording on YouTube. So if like sensitive information is shared, that's going to stay there for long, let's say, right? Right, so I'm starting Rhino again, and let's have a look if our simulation is actually ready. All right, let's go to perspective view. As I said, I don't need to load any Rhino file actually. So I'm logging in. So you see now I see back the our projects that we've started running now. So I'm going to go into the one I created an hour ago, and let's see if that's done. So run pedestrian comfort, not yet. Unfortunately, I now lost the connection in that text file. And I only have the email, so I don't have, I need to ask Richard on the SimSkill site to log in. If you're running it on your own account, you could actually log in on the platform and see the runs progressing. That's another way of checking it. In this case, we don't. So we started, when did we start the simulation? It was estimating around 45 minutes, if I remember correctly. So we started that, yeah, 43 minutes. So between 34 and 1.5 hours. So that it's always a range, right? But we started at 12:03. Yeah, that's probably just a bit too tight. Let's give it another 5 or 6 minutes to check. All right. That's what I had to show so far. I mean, we'll try in a few minutes again if we can visualize that roof comfort there as well. Any further questions? Any further comments? Early feedback already also welcome.
Got like a half a question that you can watch me stumble through the rest of it.
That's fine as well.
Is there a possibility, just thinking of the computation time and charge per GPU, to maybe isolate just a single point in time run? If you take that point in time from the 8760 data and the wind speed and the wind direction, can we isolate that rather than running the full 16 or 32 direction calculation, if that's making any sense?
Yes. Yeah, you can. So that's where I still need to go through the user interface a little bit, because we're calling it structural loading run now, right? The second option of running it. Actually, let me show you. Let me show that on the screen. And on that part, what you do is, so let me load the London model again. You choose which directions you want to run, and there's no climate data attached to it. So that would be a single point in time in a way, right? So if I create a new project again, to be honest, it doesn't really make a difference. So create project, I'll load my layers. So that's all the same. Import geometry. So again, the resolution low, medium, best, but if I choose here structure loading, and I think I should convert that to a single direction run or something like that, or individual directions, because if you choose that and I press continue, you get this windrows. And in here, you can actually click, okay, I want a 0, so wind coming from the north, or 0 and 45. And maybe I want that one. And I press continue. Then you see it here already. If you choose the direction individually, you only have a 0, a 45, and a 112. Or for instance, if I go back, I turn them off. I only want the 0. In this case, it will be still city. And continue. Because you're running a single direction, it skips the weather file page, right? It skips the 16 directions, and it skips the comfort criteria and putting in that weather file. So now you would have just single direction, just speed. You would need to do some multiplications yourself in a way, right? But this is kind of the one moment run. I think what we do need to do, connecting back to the other question earlier, I think what we also want to put in is a wind speed as an input, right?
What is it currently used for wind speed default?
10 meters per second at 10 meter height. And that's then a logarithmic profile, let's say. That's kind of the typical thing you would use for pedestrian comfort, because it multiplies up and down quite nicely because it's logarithmic. So you kind of log 10 cancels out a term in the division, basically. So yeah, I think we do need that wind speed input in a way, so that you would have, so basically you could look at, okay, I don't know, June 16th, 3 o'clock in the afternoon, my wind speed is 3 meters per second, and I could put that in. Or alternatively, if you do a structural loading, my design wind speed is 33 meters per hour. Let's run it for that.
This would be a wish list item and probably down a completely separate track, but how some of us maybe isolating that data is often through the Grasshopper script. So if Nuada could ever connect to Grasshopper through some components, I think that would be a huge help.
It actually can. The thing is, I have a set of components which does this API talk as well. It's just we haven't finished them as of yet to be ready to release, you'd say, right? Because this app is a lot more packaged in a way, right? In Grasshopper, you kind of need to expose a bit more, or even, and I don't like to do that, like hard code it into the component, right? But then as a user, you would never be able to access it or see it or know what's even there. So I tend not to do it. No, and I think, to be honest, that's roadmap, right? Like Grasshopper would be a nice connection, definitely. The other thing is as well is this is quite a modular way of how we've made this app. So I could also really quickly seed this as a Revit app. And the way the app is built is we only have to solve the mesh import in Revit, basically. Like the backend of packaging up the CFD simulation and sending it to SimScale, that's actually done. If we sort the mesh import, it's kind of there. So the idea is to fully round this up in Rhino first, and then start jumping into different softwares, hopefully. So it's Grasshopper, of course, is almost number one. I think we all love it. Revit is probably a number two because it just opens up such a big market of users. But as well, if I'm thinking internally within Thornton Tomasetti, connecting directly into a SAP or ETABS, which is a structural analysis software, so that in the ETABS is organized by building floors, for instance, right? So it's very convenient for your tall towers, your repetitive, and I think it would be pretty amazing to maybe start in Rhino or even start in ETABS, but then when the simulation is done, you basically in ETABS pick up the results, because that's the other thing what an app like this allows you to do, it to start in one software and pick it up in another software. So for instance, start your model in Rhino or in Revit, run the simulation. When the results is done, get it into ETABS and get your loading per floor or something like that. Yeah, right. That's roadmap. That's getting it. Let's round it up this year first, nicely for Rhino, and then we'll get there. Yeah, but then again, if you have any wishes of that, yeah, keep them coming, definitely.
Those are the ones that come to mind. Looking forward to those plugins. Thanks.
Cool. I'm going to try once again if we get some results. There we go. We got results. So let me hide that stuff here. So now we just finished our 45-minute run, actually. So you see, we can choose the run here, pedestrian comfort. So let me do that once more. So I can go back. So this tile up here, that really is kind of go back to projects page. It's like a back to home. but it's also when I'm here, it's a refresh. So if I click this again, it actually starts refreshing this list of projects. Now we only have a few, so it's pretty quick. You notice that when I was in my own account, I have a lot more projects, so it actually fetches all of them, takes a bit more. So yeah, be patient when it grows up. So I'm going to go into the project I set up, but feel free to pick up yours. I'll get to the question in a second. So I can choose run pedestrian comfort. So that's the one run that we've initiated 45 minutes ago. And there's a whole bunch of results. I mean, again, work in progress. We need to make this a bit more understandable. This is how we get it back raw from SimScale. So they like to put it per direction. And so you got a 135, for instance, has 5 buckets of results. You got an average solution, you got a transient solution, you always have that. Then you have some additional results. So these are those results that we clicked on in the settings. I'll get to that in a second. That holds for all of these 16 directions. And then in the base, you got your statistical surface solution. Actually, I want to get that pull down menu. Let me try. I don't know, it doesn't really matter which one I'm gonna pick. Let me try an additional average results for instance, winds coming from the southwest. So I'm clicking on the download button because it says please download the results first. So this first icon is a download button. I'm doing that first, and that saves it into my documents folder. And then when that's done, it populates this area with whatever data I have in that bucket of results, right? So, and by default, it turns data on. Doesn't visualize yet because it might be heavy to visualize. And then you got some solid inputs. That's the input geometry. So your ground or group all volumes, that's your meshes. So I can turn the visualization on. So you can toggle that on and off the visualization. If you flip through these fields, you might want to turn it off, change some settings and turn it on again. Because the thing, and that's again, work in progress, that's where we need to play a little bit. Now it only shows data and nothing of the input buildings, let's say. So I'm going to turn that solid 2 on, which is all of our buildings. The other thing it unfortunately does now, because we have surface exports, remember that I turned that on for the building. If you have surface exports on and the all volumes on, it shows both over each other. So it's not that pretty. That's something we need to fix. However, you see you have a vertical plane, so that's your Y0. You got a horizontal plane Z0 and a horizontal plane Z1. And you can flip between velocity or pressure. Takes a second to load. There you go. That's our pressure fields, and you can see that the tall. This is the cheese grater, the diagonal Rogers building. It's really hitting the first area of wind and creates that wake behind. Now, alternatively, let me go into that statistical surface solution. All the way at the bottom, there is this statistical surface solution. So that's your pedestrian comfort. So if I download that, that's typically a very small data set. Sorry, that pull down menu still doesn't show up. And I'm showing the group all volumes. I need to check what's happening there. That's our comfort. It's very similar as what I showed in the previous case. Unfortunately, the zoom is always a bit funny. So zoom extends and zoom selected works in Rhino. So it kind of resets the case. Why do I not have any results here on the roofs? That's a little bit obscure because we put that on, right? Okay, something to investigate. We should actually have I thought, results on these roofs and the context and that one. That's a question for myself. What's happening there? Apologies for that. I'll check it out and figure out what's happening. We had another question. Oh, Martin needed to jump out. Okay, cool. No, that's fine. Thank you so much. And definitely see you in person tomorrow. Yeah, so that's kind of where we're at in terms of visualization. I mean, there's still a bit of work to do here to, first of all, make this more human readable. And also like these 5 buckets of direction, they really need to be jumped together, and being able to flip one by one. As I said, making this actually be usable geometry and data, that's definitely step number 1. And then, yeah, thanks for all your questions and comments. We'll add it to the roadmap. And I think definitely like getting that data out in terms of points, or even post-processing now, perhaps like putting in a mesh and a set of points, and from this result post-processing, I think would be very valuable actually, so that you can always change your points after the fact, because that's the one downside of the way SimScale runs their solver and only stores the results you preset. It might be useful to have that as a post-processing in the app as well, or through a Grasshopper component. Because now it's Rhino geometry, so now we can do Rhino interpolations and all that stuff relatively easy. Cool. I promise you to share a few of those files. I'll drop them in that same Google folder. I'll drop in that microclimate guideline of the City of London. So let me pull that up where I have that. So that might, this one, wind microclimate. They've also actually had, so this is regulation now for planning. So the City of London specifically, so that's really the financial district in London. It's not even the wider London, but they've pulled in these requirements, and more cities are now following it. So they came up with categories of when do you need to either do wind tunnel testing or CFD simulation, or even for the taller ones above 100 meter, they now want to do it both by 2 separate consultants, which I think is actually good. And because they are really diligent in how they prescribe their wind data, which is a big factor, and their reporting styles, it really levels the playing field, which is actually really nice. It really helps the whole stuff forward. And it tells you as well, like, at a minimum, we need to look at the existing site. We need to look at a proposed scheme with existing surroundings, or a proposed scheme with planning consented schemes. So these are schemes that have planning, not been built yet, but they are very likely to be built before our building of study, right? And then there's a few other sets of simulations, like if mitigation is required, you need to show that, etc., etc. And then they go into very detailed wind tunnel test requirements. If you run CFD, there's requirements, and this might help you as well get a feeling of what would be a good CFD model. So I'll happily share this with you. And then they even prescribe the comfort criteria plus coloring you need to use in the visuals. And then ultimately, this is the wind climate. This is the input side of things and how you calculate the comfort. So it's very prescriptive. But as I said, I actually like it because it really levels the playing field. it makes it a lot more readable and comparable. And they've also done a thermal comfort guideline, which is it's kind of in draft / they want you to do it, but it's not a no-go decision yet. But this is where they're actually pushing, and we've commented on this document, where they want to combine and the CFD simulation with UTCI thermal comfort index. So I'll drop that in the folder as well, because I guess reading the room, let's say, I guess people might be interested in this, let's say. And again, it prescribes computationally how you should do it actually, and what needs to be included. Anyway, that's homework. That's side reading, let's say. Any final questions or comments, or otherwise we're right up at 1 o'clock, so that's perfect in timekeeping. All right, thank you very much.
Thank you.
Yeah, thank you very much.
You're welcome.
Thank
More
you.
than welcome. Cool. All right. Bye-bye.
Thank you. Bye-bye.
Bye-bye.